Now the last part that we're going to do is solving by using a table. We set this up basically the same that we were doing before. This part goes into y1, that goes into y2. So I'll clear that out and type in x squared plus 5x minus 7. y2 stays the same at 0. Now instead of looking at a graph, let's see how we could solve this by looking at a table. When we're solving by a table, we're looking for y1 and y2 to be the same number. So we're going to press up and down, scrolling until we find it. So looking, it looks like it's going to be somewhere between 1 and 2. So between 1 and 2 is kind of an approximate answer, but we want a more precise answer. So we're going to set our table up a little differently. Press second window, and let's start our table at 1, but let's start going by maybe tenths. So 0.1. Now when you go back to your table, it's going by 0.1. So now we're looking and we can see, well, somewhere between 1.1 and 1.2 it hits. So then let's go back and set our table again. And we want to start it at 1.1, and now let's go by hundredths, so 0.01. And we can look and to see which number is closer. This number is actually closer to 0, negative 4, e negative 4. Recall that e negative 4 is actually the calculator's way of saying scientific notation. So that number is actually negative 4, and then move the decimal 4 spots. 1, 2, 3, 4. So it's negative 0.0004. And that's the closest that we get to 0. So we would say that our solution is at about 1.14. But now remember, we should have two solutions, so we need to go back and find our second one. Okay, table set again, started at 0, and now let's jump back to going by ones. Go back to your table now, and we need to scroll around until we find it. Oh, it looks like it's somewhere between negative 7 and negative 6. So we go back to our window, start it at negative 7, and go by tenths. Go back to your table. And where is it close to 0? Oh, we're getting really close right there. So between negative 6.2 and negative 6.1 is where it switched from positive to negative, so that means it crossed over 0. So go back to your second window. Start your table at negative 6.2, and now we change it to hundredths. Go back to your table. And there it is again. The closest to 0 is right there at negative 6.14. Now I want you to only go to the hundredths. You could go even further and get a more precise answer, but hundredths is fine. All right, so most of the time this isn't very feasible to do, or it's just easier to do it by graphing. But sometimes when we get a real world problem, it's hard to find the graph for it. Then we want to rely on a table. Okay, so let's put our numbers in here and see which way is going to work the best. So we've got the Royal Gorge Bridge in Colorado. Its height above the river is 1,053, and you're dropping a marble over the side from a height of 3 feet above the bridge. How long will it take for the marble to reach the surface of the water, assuming there's no air resistance? We should use this formula. So HO is the initial height. So our initial height is 1,053, But in addition to that, we are also 3 feet above that when we're dropping it. So we would go h of t is negative 16 t squared plus 1056. Now we need to figure out how long until it hits the ground. Well, when it hits the ground, the height is going to be 0. So we are really solving when h of t equals 0. Okay, so if we put this into our calculator, clear that out, start at negative 16x squared. And I'm just going to try hit and graph, see if we get anything. And it actually is working. Okay, so if we think about this, we should be changing our window to go to a maximum height of 1056. So I'm going to actually go, let's go like 1200, just to get a ways above it so we can see the graph a little bit more precise. Okay, that's what our marble looks like. And this part of the graph does not really apply. This is where we start dropping the marble, and this is the falling marble over time. So we need to know this point right here. When does it hit the ground? And I'm just going to double check. I think I have a 0 in there, and I do. I'll get rid of these scribbles. So then I can just do second trace 5. I'm going to move my cursor over there just so I know that I'm going to get that answer. Okay, close enough. Enter, enter, enter. Oops. Hold up, my calculator's going a little strange. Enter. All right, and so this tells us that our intersection is 8.12. And since this is a word problem, we would need to label this as seconds. Now, keep in mind there was another intersection point. I need to change my window though. There was another intersection point over here, but that one really doesn't apply to us because that's negative time, and we don't care about negative time. All right, make sure that you update your summaries and your questions and let me know if you have any questions. This is the end of lesson 5.2.